Hey everyone, today I'm here to present RideSafe, a tool that I developed with Professor Robin Cohen at the University of Waterloo that helps to detect sexual harassment in rideshares. Let's consider Uber, a multi-billion-dollar company that completes 14 million trips each day. Anyone with a valid license can participate in driving Ubers and make a living for themselves. 14 million is more than the populations of New Zealand, Denmark, and Singapore combined. And what do you have when you have such a huge network of individuals traveling in strangers' rideshare? Well, everyone here has had some elder in our family tell us, well, don't get into cars with strangers, don't meet people from the internet. Now we have Uber. And of course, we have issues. 3,000 sexual assaults were reported during US rides in just 2018. And now there's three things to consider here. These are only the reported cases. We got to understand because of the stigma attached to sexual assaults, a lot of these cases don't come forward. These are only in the US rides, and this is only 2018. There's other countries out there that have more pertinent issues with Ubers, such as India. And what can we do about this? Let's adapt the same approach we have for departmental stores. The same way departmental stores have security cameras, let's have voice recording systems set up in Ubers. So this would solve two purposes. Psychologically, it would deter cases of sexual harassment because the person who is subjecting a passenger would know that their voice is being recorded and they will be caught. Second, let's use machine learning and AI to identify these cases of sexual harassment using these voice recordings. If a voice recording signals a case of sexual harassment, we alert the authorities and the rideshare company, and then they take care of the rest. So for the technical solution of this, we look at the RAPTES dataset. It contains 24 professional actors, 12 female and 12 male, vocalizing phrases and sentences in different emotions. For the purpose of this project, we're trying to classify the voice recording of a female sounding fear, sounding scared, and all others. And we believe through our interview of 25 women of different nationalities and age group that their go-to response would be one of being very scared if they were stuck in a rideshare situation that was not pleasant or not ideal. So for this, we take the voice recordings and then we use MFCC, Mel-Frequency Cepstral Coefficient. We move the audio to the frequency domain using MFCCs. What MFCCs really do is that they map audio to power spectrum that allows computers to understand audio the way we do. We also consider pitch in our models. Once we have all these features, we run them through three different machine learning slash deep learning models. The first one we used was support vector machines. We take fear in a female voice as a positive class and every other voice as a negative class. And then we try to classify between them using a support vector machine, and we get an F1 score of 91%. Next, we use a convolutional neural network that uses the MFCCs entirely as an image. What that allows us to do is that we can convolve over the different parts of the MFCC and then try to identify the voice as fear or not, or just every other emotion, and we get an F1 score of 95%. Lastly, we use a long short-term memory model, which is a stacked LSTM with 3 layers, which allows us to get an F1 score of 90%. Let's get into the results and discussion. Friends, our major goal over here is to minimize FNRs. We cannot let even a single case slip through the cracks of our voice record of our system. Every single life matters. So at the expense of having a higher FPR, we would prefer a very low FNR because A higher FPR can be solved with a bunch of different solutions. We can have manual checks at the companies. We can have the companies alert the passengers and ensure that the ride is going okay. We can also offer a hybrid model, such as an SVM and 1D CNN. If you look at the results, SVMs minimize FPR, whereas CNNs minimize FNRs. So there's a ton of solutions that we can come to that, but our main priority is to minimize FNRs. And while this is a proof of work and this is just in its starting stages, we understand the solution is not perfect and there's obvious problems and threats to solution. The first one being fear can be attributed to other reasons, which is not just sexual harassment, which would lead to more false positive, but who cares? We'll figure it out. We'll figure out a way to deal with them. Next, response to trauma might not always be emotional. Some passengers might just want to be composed and calm to avoid any confrontation with the driver. Some might argue that recording voice in rideshares might pose a privacy violation. It's the need of the hour. Every person who's driving an Uber would have to agree to having their voices recorded in the Uber. And then again, department stores have cameras, public spaces and public offices have cameras. Why do we not have voice recordings in Uber when it is, by in essence, a public space? This might just create a system of distrust with the drivers, but there is no other alternative. Our passengers' lives matter more. And for that matter, if it's a female driver, then her life matters more. This goes both ways. And again, this might be an issue of saving sensitive information that cybersecurity concepts such as access protocols and who gets selective access to information has been a majorly solved problem. We have solutions from it. We just need to tap into our cybersecurity research and techniques, and we'll figure out a way. Lastly, again, this is just the first step. We need to save passengers from being sexually harassed in rideshares. And other steps towards this might be incorporating data for other at-risk groups such as transgendered. We could integrate text analysis for the voice recording to further identify harassment. And even if we save one life with this, one case of sexual harassment, it's a win. And if I, a broke grad student, can come up with this solution, I'm pretty sure a multi-billion-dollar company like Uber can too. Thank you. I'm open for questions.